Hello and welcome to my YouTube channel Statistics with R. In this video, we are going to see how to conduct correlation analysis in R, as correlation is one of the statistical technique which we are using whenever we have to study the linear relationship between the variables. In this video, we are going to use the sample data consisting of the 7 variables, and we want to see in this video that how to see graphically the visualization between the variables, how to compute the coefficient of correlation, how to test the significance of correlation coefficient, and how to visualize correlation matrix. As you can see the data, we were having 7 variables. First, we will try to see the relationship between the variables by producing the scatter diagram, which is a graphical visualization of the bivariate distribution. So we will first attach the data, then we will use the plot section. On x-axis, we want to put the one of the variable as a pH, and another variable we want to put on the y-axis is a calcium carbonate. We will run the function. As you can see, a scatter diagram is produced where you can see the points are moving diagonally in the upward direction. It is an indication that there exists a positive relationship between these two variables, pH and calcium carbonate. Now, if you want to visualize the another variable, let's suppose we will plot pH, and we will be having another variable, bulk density, which is stored in the data. So as you can see in this scatter diagram, that these points are not having any specific direction, as these points are spread across all this two-dimensional plane. So it is an indication that there exists no correlation between these two variables. So whenever we have to see the relationship between the variables, it's imperative to first see the visualization between the two variables by producing the scatter diagram, which will give us the overview of the relationship between the variables. After seeing the scatter diagram, now let us start computing the coefficient of correlation. So in R, there's a one function which we are using to compute the correlation function is the COR function, which is available within the base package stats. And within this function, we have to put the name of the variables for which we want to compute the correlation. So the variables are stored in the data. So I want to see the correlation between the pH, and the second variable I want to see, with which I want to see the correlation, is the calcium carbonate. So to estimate the coefficient of correlation, we are using the core function. Then first argument, we will put the name of the first variable, and the second argument is we will put the name of the second variable. So we will run the function. So after running the function, as you are seeing on the console, the coefficient of correlation estimated by this function is 0.89. It means there exists a high strong correlation between these two variables, pH and the calcium carbonate. Let's suppose we want to now estimate the coefficient of correlation between pH, and the second variable we want to put in is the bulk density. So we will run the command. As you can see, now the correlation between the pH and the bulk density is only 0.28. That means there's a weak relationship existing between these two variables. This is how we are basically computing the coefficient of correlation between the two variables. Now, if we want to compute the correlation between all the pairs of the variables, for that what we will use, we will put again this core function, and within the core function we will simply specify the name of the data set for which we are going to compute the correlation between all variables. We will simply run the function. First, I will resize the console portion so that we will be able to view all the correlation coefficients. So we use correlation function, and within the data, we will simply provide the name of the data. So after that, as you can see on the console, all the coefficient of correlation between the various variables are printed on the console portion. As you can see diagonally, this diagonal elements, these are called the variances, and the off diagonal elements are called covariances, which are basically the correlation coefficients between the two variables. And Below diagonal elements we call the lower matrix, and the upper we call the upper triangular matrix. So this is how we compute the coefficient of correlation between by specifying either the name of only two variables or by specifying the name of the whole data set. Now, after obtaining the coefficient of correlation, we want to see whether this coefficient of correlation is statistically significant or it is statistically non-significant. For that, we are using the core.test function, which is available within the stats package, which will test the significance of this correlation by applying the t-test, as t-test is being used to test the coefficient of correlation coefficient. And within the parenthesis, we will first put the name of the variable as a pH, then the second variable for which we are going to compute as well as test the coefficient of correlation is the calcium carbonate. We will simply run the command. As you can see on the console portion, it is saying that we are computing the Pearson's product moment correlation, and the coefficient of correlation which we have already computed is 0.89. Along with it, it will give the value of t statistic degree of freedom, as well as it will give the probability value, with the help of which we will tell whether this coefficient of correlation is statistically significant or not. As you can see, the value of p is very less. It is less than 0.001. So it means that correlation existing between these two variables, pH and the calcium carbonate, is statistically significant. So, but in this function, we will be only able to compute the testing the significance between these two variables. To test the significance of all the pairs of correlation, we will first be using using one library which is called GG code plot. Because what we are doing in this function, we are simply obtaining and testing the significance of correlation between these two variables. But if we will put the data whole data frame within the function, it will produce error because it will not be able to compute the significance of the all pairs of the correlation. So for that, we will be using one of the library which is called a GG code plot. And within the GG code plot, we have the one function which is called core underscore p mat. So before that, the correlations for all the pairs which we have computed using this command, we will store it in the object, let's suppose cor. So here in the COR object, it is storing all the uh, coefficient of correlation for all the variables. Then to basically produce the matrix of p-values for all the pairs, we will using core underscore p mat function, which is available within the GG core plot function. Basically, it gives us the matrix of the p-values. So we will use core underscore p mat. Then within the argue within the brackets, the argument which we have to give is the core. Core stands for the it is the object within which we have computed all the pairs of correlation. So we will store this it into, let's suppose, P matrix. I will use P matrix, P mat object. So I will store this into the P mat. So if we want to see the P mat object, we will simply highlight the P mat object and we'll run the function. As you can see that this is the matrix of the P values, and this matrix will tell us whether whatever the correlation is between the variables, whether that correlation is statistically significant or not. So this is how basically we are using the core function to estimate the coefficient of correlation for all the pairs of variables. And this core underscore pmat function, which is available within the GG core plot, is used to obtain the matrix of p values for all the pairs for which we have computed the correlation. So this is how we will compute the correlation. Now, what we will do, we will try to visualize all these correlation coefficients along with the p matrix values. And for that, we are using the GG core plot package. And within GG core plot package, we have the function GG core plot. And the first argument which we have to put within this GG core plot is the correlation matrix which we have computed and stored in the COR object. So the first argument is CORR, and we have stored the correlation in the COR function. And the second argument which we have to put it in is the PMAT object. That means we want to specify the matrix of the p-values, and that matrix of p-values which for all pairs of correlation we have stored in the p-mat. So we will put p-mat. Then we want to, whether we want to mention the upper triangular matrix or lower triangular matrix. Let's suppose we want to give is the lower triangular matrix. So this is a function argument which we have to give to produce a lower triangular matrix. And if we want to plot the all the values of correlation coefficient, we will the live function, and we will it's a logical statement, and we will set it to the true. So now we will run this script. So after running the script, as you can see, a plot uh, has been produced, which is visualizing our correlation matrix in the form of graphical visualization. As you can see, it is giving the continuous scale, where you can see the more the red color, the more the coefficient of correlation is, and the more the blue color, the more the coefficient of correlation is, but that correlation is negative, and the red correlation is basically the positive value. And as you are seeing the cross signs on each coefficient of correlation, it is an indication that these correlation coefficients are basically non-significant. So we are doing two things in this GG core plot. We are producing the correlation matrix. Then second, we are visualizing it in the form of the colors. And the third thing, we are putting the significant, non-significant correlation by putting the cross sign on these correlation matrix. Along with it, you can also give the title to this correlation matrix by using the title function. Let's suppose we want to give the title correlation between uh, between different properties of a soil, properties of soil. So I want to just run the function, and you can see the title of this graphical visualization there. Now if you want to change the title of the legend, so you can use the legend.title function, which is available here. So let's suppose we want this coefficient of correlation, coefficient of correlation. So I will again run the function. As you can see now, the title of the legend has been changed to coefficient of correlation. So this is how basically we are doing this correlation analysis in R, by scatter diagram, by computing the coefficient of correlation, by testing the significance, as well as by visualizing this correlation matrix.